Let's go to Liquid 53, maximum Subarray. It give us injury nums, and let's find the maximal, the subarray which have the maximal sum. And previously, we already did this question, use a prefix sum. And we keep a variable called minimal prefix sum so far. And for every number we see, we add in, we just use add it to a current prefix sum, then minus the previous minimal one, right? And then have the result compare with the global result. So, but for this one, we have another one called algorithm called the Kadane algorithm, which means we if we for every number, right? For every number we add to if we have for example, this is we use a variable called current, which means the maximal subarray end with index I. For the index I plus one, I will have two options, whether we to start a new subarray or we add to the current, right? So depend on which one is bigger. For example, if the current is a negative one, negative number, we don't need to add this one to the previous one. We can start a new subarray. So the concept is we have the option to add to the previous calculate and the largest subarray end with I, or we start a new subarray. So we use a variable called current, which means that the maximal subarray we end with I. And also we use a variable called max so far, right? That means in the previous this kind of range, what is the max subarray we see. So every time we calculate the current, we have the current is the because the current is the max subarray with n with I, right? So we compare with max so far. That is our result. So let's have max so far. We can just have a result, right? Let's have a code for this. So we have int result equals nums. Let's set from let's from index one. Because the reason is that if we have, for example, nums equals to -1, right? The max will be -1. If we start from result to be 0, 0, if we set a result to be 0, it will be 0. That will not be incorrect. And we have current equals nums there, and n equals nums dot length. So what we do is for int I equals to 0, I smaller than n, I plus plus. So we are going to have current equals max dot max current plus nums I, or that is nums I. We add this is from one, right? From because we already have nums 0. The nums I we add previous, right? Or we use a new starter from new, that is nums I. And the result will be max result in the current. In the end, we just return result. Let's write Python as well. So we are going to have result current n equals nums 0, nums 0, and the length nums. For I in range from 1 to n, right? Current equals uh, next current plus nums I or nums I. And we have result equals max result in current. In the end, just return result. This ON time complexity with constant space